Section 2.5 talks about derivative of polynomials, and I'm going to add to it rational functions as well. Now, general rule. So the derivative is found by taking the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. That was section 2.3/2.4. A shortcut, if you see a power function, so I'm altering the polynomial to general rules. It doesn't have to be a polynomial. Any power function, any variable raised to a number. If you take a derivative, the shortcut is bring the power down, subtract 1 from the power. Derivative of any constant is 0. Think about it. If y equals c, that's the graph of a horizontal line, and the slope of any horizontal line is you don't rise, you don't go up or down, but you move to the right or to the left, and 0 over any non-zero number is 0. And derivative of x, or I should say mx is m, or derivative of x is 1, meaning if you think of it as the power rule, that's x to the 1. If I take a derivative of that, I bring the power down, subtract 1 from the power, and any number to the 0 power is 1 other than 0. So the rule is fairly simple. If I take a derivative of a constant, that's 0. Done. That's the shortcut. Instead of taking the limit as delta x approaches 0 of, the traditional, here, if I want to take a derivative, that's a power function. Bring the power down, subtract 1 from the power. So again, this section, they deal specifically with polynomials. I'm going to deal with any power function. Save us time because we don't want to squish other sections together. Here, the same deal. This is a radical, a cube root of x squared. If I want to take a derivative, bring the power down, subtract 1 from the power. If you take 2/3 minus 1, that's negative 1/3. So g prime is 2 over 3, and this is going to move down and become the cube root of x. And you don't have to rationalize, not in this case. Now, if you've taken a derivative and you see that there's a function multiplied by a constant, ignore the constant and take the derivative of the function. If you see two functions added, like those, take a derivative of each and just add the results. And if you see them subtracted, the same deal. So when I look at example 2a, I notice that's a power function. Bring the power down, subtract 1 from the power, copy the minus. Here, the 2 you ignore. Derivative of x cubed is bring the power down, subtract 1 from the power. So the derivative is 4x cubed minus 6x squared. If you were to take the limit as delta x approaches 0 of f of x minus f of x plus delta x minus f of x over delta x, which is the difference quotient formula of this mess, you will get that. And here the same deal, a derivative. The 2/3 you ignore, bring the power down, subtract 1 from the power. Derivative, ignore the 5. Derivative of x is 1 and derivative of 1 is 0. So f prime is actually 2x squared minus 5. That's simple. This is the shortcut for a derivative, and we're going to be using that for the majority of this semester. Well, if I think about it, you're really, when you bring this down, you're multiplying those. Do you notice that? So 4 times 1.2 is 4.8x cubed, plus, bring the power down, 2 times 3.5 is 7x, plus 0, no need to write plus 0, and there it is. So very quick and efficient way of finding instantaneous rate of change, velocity, slope of the tangent. It has so many names. If I want to take a derivative of n, to bring the power down, c is a constant, so ignore that. Negative 3 times c is negative 3c. And if you subtract 1 from the power, that's to the negative Now when do you move the negative down, and when do you leave it? If you start the problem with negative powers, you could leave the answer with negative powers. If you came with negative powers from the derivative and it wasn't initially negative, like we did right there, that was a positive power, then you really move it down. As far as calculus, we're not gonna really disagree, and you're not gonna lose any points if you don't really bring it down, but on the long run, we're gonna have to do that. Same deal here. If I take a derivative, bring the power down, negative 2 times 5 is 10, subtract 1 from the power, bring the power down, 5 halves minus 1, which is 2 over 2, is 3 halves. So f prime is negative 10x to the 4th. 2 divides 4 2 times, plus 10x to the 3 halves. So the shortcut is really short compared to the alternative. Here, I need to manipulate the problem just a bit. I'm going to say f, so no calculus yet. That's radical 2 times x plus radical 5. I'm going to move this up. That's 3x to the negative 1. When I take a derivative of x is 1 times radical 2. That's radical 2. That's a 0. Bring the power down. Subtract 1 from the power. So f prime is radical 2 minus 3 divided by x squared. That would be my derivative. Here I need to manipulate that a bit. That's really 3 over 6t squared plus 2t to the 4th over 6t squared. So I could say that k of t is actually 1 over 2, and I'm going to move this up, plus 1 over 3, and t to the 4th divided by t squared is t squared. K prime is, bring the power down, negative 2 times a half is negative 1. Bring the power down, 1/3 times 2 is 2/3. And bring that back down, and k prime would be negative 1 over t cubed plus 2t over 3. Now, we have a product rule. Suppose that f and g are differentiable. In the product rule, if you're multiplying two functions, then you take derivative of the first times the second plus derivative of the second times the first. You could do that in any order since those are added. But if you apply the quotient rule, if you have two functions divided, then you're going to take derivative of the top, it's right there, times the denominator, minus the negative must be in front of the derivative of the denominator, all over the denominator squared. That's just a rule. So product rule, if I'm taking a derivative of two functions multiplied, of course I could distribute those in, but it's a lot of work. Derivative of the first times the second plus the first times derivative of this, which is 3t squared plus 5. For now, that's all you need. Later on, you're going to have to set that equal to 0 and simplify, but for now, that's all we really need. And if I want to take a derivative of this, again, applying the product rule, derivative of the first is 2x plus 1 times the second, whatever that is, plus the first derivative of this, bring the power down, subtract 1 from the power, bring the power down, subtract 1 from the power. Now, about, let's say, 20% of the time you're taking a derivative of specifically square root. If you take a derivative of a square root, you write it as x to the 1/2. You bring the power down, subtract 1 from the power, so it's 1 over 2 radical x. Now, this worth memorizing. Only a square root, since you're going to see it roughly in 1 in every 4 problems and 1 in every 5 problems, you're going to have to do that. It's worth remembering that the derivative of a square root is 1 divided by twice the square root of x. Here, I notice I have the quotient rule. m prime is derivative of the top times the denominator. Now the minus must go in front of derivative of the denominator times the top. So derivative of the denominator is a 1 times the top all over the denominator squared. This is nothing more than me memorizing that rule. Now on an exam, that's all I want for now. For the homework, you're going to clean it up. X minus x, they're going to cancel out, so you're going to be left with 2 over x plus 2 squared. That would be the answer in the back of the book, and that's what you need to do on the homework. But for the exam, you just have to show me the calculus part for now. Same deal with that problem. That's the quotient rule. Y prime is derivative of the top, that's 2x, times the denominator, minus the top derivative of the denominator is a 3 all over the bottom squared. Again, on a homework or on the exam, you could read the answer like that. So anything I box is accepted on a test. Here you're gonna have to clean it up for the homework. That is 6x plus 6x squared plus 10x minus 3 times x squared is minus 3x squared, and minus 3 times 1 is minus 3. Combine like terms and you're done. So that would be 3x squared plus 10x minus 3 all over 3x plus 5. Luckily the top doesn't factor, so you're done. And here we are. Derivative, again, it's a quotient rule. Derivative of a radical, it's worth memorizing. It's 1 over twice radical x. That's derivative of the top times the bottom, minus the top derivative of the denominator is simply 1 over the denominator squared. So this is a complex fraction. LCD is 2 radical x. So if I make each of those over 2 radical x, I'll simply have a single fraction. So LCD is 2 radical x. This is missing nothing. This is missing 2 radical x. And this is missing 2 radical x. If they all have the same denominator, you ignore that denominator. That's x minus 1 minus 2 radical x times radical x is 2x over twice radical x into x minus 1 squared, and that simplifies a bit more. Again, on a test, this is all I want. This will be negative x minus 1 over twice radical x into x minus 1 squared. So the quotient rule, something to really get out of the way. Here, for now, y prime is derivative of the top is 0 times the denominator minus the top derivative of the denominator is 2x plus 3 over the denominator squared. Now, the fact that this is a 0, pretty much undone. The answer is negative 2x plus 3 over x squared plus 3x minus 5. So the homework is going to reflect a portion of 2 sections. Now, something to really get out of the way, something that's going to come up a lot. Tangent line is extremely important for us. We know a normal line is perpendicular to a tangent line, and we know the slope of the tangent is the derivative. We talked about it in the last section. So if you look at the graph, if this is the shape of the graph and it's heading in this direction, that's the slope of the tangent. So it kind of gives you an idea how the graph is pointing and how sharp are those changes, from increasing to decreasing. That is the normal line. Again, it's very useful. So on the next example, it says find an equation of a normal line. Well, I know how to find an equation of a line. I'm given a point y minus y1 equal m into x minus x1. Well, guess what? I'm almost done. The only thing missing is the slope, and that happens all the time. How do you find the slope? You take a derivative. The root of the top times the bottom minus the top times the root of the denominator all over the denominator squared. Here I need to evaluate that at x equal 2. It's easier to get it this way than to clean it, because cleaning it's going to take some time. A 2 in there, that makes that a 4 minus 2, and a 2 in there makes that 2 plus 2 squared. So the slope of the tangent is 2 over 4 squared is 16. The slope of the tangent is 1 over 8. So the slope, this is the slope of the tangent. We know that a normal line is perpendicular to a tangent line. So the slope of the normal is the negative reciprocal. Negative reciprocal of that is negative 8. Of course, there are other ways you could find an equation of a line. Any one of them will do. And this is pretty much section 2.5 and a portion of section 2.7. 2.7 has 3 things. Has product rule and quotient rule, we just did those two, and has chain rule, something I want to spend enough time on because it's really crucial and a bit tougher to see. That would be it for this section.